Yep, let's get started. So welcome everyone. Welcome to another RISC-V technical talk or technical session. As this is a member-only meeting, I'm going to run the disclosures for now before we get started.
Hi, I'm Mark Himmelstein. I'm the CTO for RISC-V International, and these are the disclosures. Only RISC-V members may attend. This is in order to protect our IP rights. We have an agreement when we become a member. It's important that anybody who goes ahead and joins a meeting includes their name of their affiliation, their company, or if they're an individual, say individual, or an institution, so everybody knows where everybody comes from. We have an antitrust policy. We abide by the regulations in the United States and other countries. There is a link at the bottom so you can check that out. We are a collaborative and welcoming community. There's a code of conduct. If there are any issues, please contact as specified in that code of conduct website page, or send mail to help@riscv.org. But we're intending to be more than just not violating code of conduct. We want people to feel welcome. We want to have them feel included, and have them feel like they could share their ideas and not feel threatened in any way, shape, or form. We do have meeting conventions. We start our meetings for 1 hour at 5 after. We tend to try to not a rat hole. If there is a topic, then we either handle it in email or schedule a time to do that. We worry about people's time zones and other things, so we try to make meeting times. Obviously, there's a lot of competition for 7 a.m. Pacific time, and we try to accommodate as much as we can. So welcome to the meeting, and hopefully, if there are any questions, we can get them answered. You can always send mail to help@riscv.org, and thank you very much.
Thanks, Mark. So, folks, today's session is going to be presented by Bill McSpadden, a seasoned technical expert who is one of the core maintainers and contributors of RISC-V Sail model. This is a very interesting topic, is a hot topic, and so without further ado, so welcome, Bill.
Hi, folks. Glad you could attend. This is a continuation of the talk that of the summit tutorial that I did in December. We're going to continue on with some of the topics that we didn't get a chance to get to. Raphael, would you make sure that the link to this presentation is available in the chat window so people can follow along if they want to in their own presentation. There's, as with all things Sail and all things RISC-V, you could talk for hours on any particular topic. So I've narrowed down the stuff that I'm talking about to a very specific item that is of interest to a number of people, and that is, how do you add an extension and a CSR to the Sail model? And we're going to just take a really brain-dead example of doing that so that you know what the mechanics are like. And we'll talk about some of the problems that you're going to run into as you go through that exercise. We're going to spend just a few minutes at the very beginning to talk about what the status is of the RISC-V model. And we're going to emphasize throughout that we need your help. For those of you who have not done any Sail work, we'd very much like for you to consider joining in. There's a lot of work that needs to be done on the Sail model. We're in decent shape as far as getting the basics working. It's been used with the ACTs so that we could get cores ratified that they've passed compatibility with the RISC-V model. But there's a lot of extensions that still need work, a lot of infrastructure that still needs work. So that's the topic for today. If you've got questions, put them in the chat window, and Raphael will take care of them. And at the end of this discussion, we'll go through the questions. If you have something urgent that you really want to ask, raise your hand, and Raphael will will prompt you. Okay. So RISC-V Sail tutorial, add an extension of CSR to the model. That's what we're going to do today. Most of the presentation is going to be in the PDF document, a cookbook that we've been working on. Martin Berger was actually the guy who said, you know, we ought to have some cookbooks for this sort of thing. The cookbook that I went over at the summit was the Sail language cookbook. How do you do basic things with Sail? And we're hopeful that people will add to that document as time goes on. This is a separate cookbook, and this is how you specifically use Sail and the infrastructure around Sail to implement RISC-V instructions in CSRs. In this presentation, you've got the links to this document, a link to the cookbook. There's PDF there in the doc directory that you'll want to look at. Don't look at the .adoc that's there. Some of the diagrams did not get rendered or couldn't be found. That'll need to be fixed for the .adoc version. And then the Sail language cookbook is the last link that I have there. Let's talk a little bit about history, status, and progress, and the resources that are needed. Just a little bit. Back in 2019, which was the first summit that I went to, Rishir Nikhil delivered a talk on the RISC-V Sail model. This is a link to that talk. It's a nice little overview, about an hour and a half on his talk about how he implemented the Sail model, and that gives you the base architecture instructions, and so it's a real good tutorial to go through. The selection of Sail, for those of you who don't know, there was some competitors to it. Sail won out as the language of choice. It's a strongly typed language, by the way. That will be probably the most difficult aspect of the language. That's the thing I've experienced. It's the most difficult aspect of the language to learn and to get over. In other words, it's strongly typed, you're doing a compilation and you keep getting errors on data type mismatches, and you'll have to figure out what those are. The syntax, idioms, and constructs match what an ISA is, and that's really the benefit, is that it reads naturally for an ISA specification. And then the language is also used for backends for formal analysis, which is one of the great strengths of the language. Some resources. If you are interested in contributing to the Sail model, we have right now a weekly meeting going on, the Tech Golden Model meeting. And if you want to participate in that, you go to the lists riscv.org and look for Tech Golden Model and subscribe, and you'll get all the notifications for those meetings. Bear in mind that the meeting time is at 6 a.m. Central U.S. time, which makes it 4 a.m. On the West Coast. That kind of sucks for you on the West Coast, but I have to cater to the folks in China and the folks in UK, as they're the ones that are doing a large amount of the contributions to the model. Let's see, there's some other pointers there about some other resources. Current status, there's a bunch of stuff that is being worked on currently. I just want to bring you up to date on that. Build and release is something that we're looking for help on. One of the complaints that we've had is that getting the Sail model to build and complete on a particular compute server has been difficult, and we're trying to improve that. So we've been looking for people to help with that particular problem. Extensions that are in flight. We're in the middle of doing a review of the vector implementation. The vector implementation is quite large, roughly 10,000 lines of code, and we've broken it up into bite-sized pieces for review. We've gone through 2 PR reviews. A third one is in the wings. We're anticipating probably another 3 to 5 PR reviews before we're going to bless vector. Nambiju's been working on code size reduction and native debug triggers. SME-PMP actually has a pull request against it, but there's a few things that need to be resolved. I'm working on counters and timers that are currently up for ratification. Philip Tomsich has implemented ZICON. Another interesting note is that Alistair Armstrong has been working on a tool that will convert Sail to ASCII doc so that our Sail code can be used inside of our specifications as the definition of what an instruction, a particular instruction will do. The idea would be is if you add an extension and you have a spec for it, you would include the Sail code in the spec in an automated fashion, a very nice automated fashion. So Alistair gave a talk about that 2 weeks ago, and we're heading into getting that as part of the environment. Model speed up. Carl Friedrich Boltz has been working on some JIT methods for us, and it's shown substantial speed up of the model. That's good. So that's work that's continuing. I've been working, one of the hot topics for me is configuration. How do you configure the Sail model to match the implementation that a customer has? We'll get into this more, but imagine, so the specs are full of things that say the customer can implement this how they see fit, Worrell fields being but one of them. And we'll talk a little bit about that and how we're trying to address the configuration aspect. In short, we're trying to make use of the RISC-V config structure. There are a couple of YAML files that we're trying to bring into the Sail model. We have some working prototypes of that, and we actually have a pull request for that, but there's still some issues that have to be resolved. In the course of doing this, one of the things that Alistair, who is the keeper of the Sail language, noted that some improvements in the Sail language could help us, could help with the back-end tools, and it has to do with the typing system. So he's looking at what we can do to help improve the robustness of the configuration methodology that we're following. This is a heads up, and we really need your help, and that has to do with how are we going to test memory coherency and consistency. And so we need some work on that. Right now we have the atomic instructions implemented in the Sail model, but there's no good way of testing them. They do their accesses to memory, but there's no contention for a resource, for a memory resource. And we need to have some sort of method for doing that at some point. So in short and very brief, that is the status of the golden model. Okay, now for the tutorial. I'm going to stop sharing this document. We're going to hop to the PDF, and this is where we're going to spend the remainder of our time, is in this document right here. The RISC-V Sail Golden Model, a cookbook for the RISC-V ISA. This is not nearly as full developed as the Sail language cookbook, mainly because I've been doing a bunch of other stuff, but we really need to get to a point where this is as good a cookbook as the Sail language, and then add to it. Right now, the major item is the how do we add a new extension and a new CSR. This is a brief table of contents, of most of which is empty. We have not added that stuff. But the one thing that we have done is how to add a new extension and a new CSR. All right. Okay. So the way I'm going to walk through this is, first of all, is we're going to start off by walking through the specifications, the RISC-V specifications. There are two of them that are of prime interest, the unpriv spec and the privilege spec. And we're going to see what those specs have to say about adding a custom extension. Now, we're using the term custom extension along the lines of saying, if you want to add your own custom instructions, this is how you're going to do it. And that's what that's the direction we're going to go. It may end up that custom extension is something that might be beneficial to the entire RISC-V community. At that point, you might say, hey, let's form a working group for this new extension that we think is valuable. At which point you're going to get allocated other space in the opcode space to do your work. But for the purposes of this discussion, we're going to talk about custom or non-standard instructions. It's really one of the things that RISC-V advertises. If you want to add something to the RISC-V architecture or RISC-V for just you, you can go do this. You can do it for academic work. You can do it for your company's own interest, whatever the reason is. Okay. Now, what I'm going to emphasize is this is what is, not necessarily what something should be. I'm telling you how I developed a custom instruction and a custom CSR. What we're going to do here is we're going to develop, we're going to say, here's how you specify an instruction in Sail. And, oh, by the way, that instruction affects a CSR. And, oh, by the way, you can get at that CSR in these particular ways. And, oh, by the way, this is how you might test that instruction and that CSR. So that's the thing that we're going to talk about today. That's a lot of information, and hopefully we'll be able to get through it all in the time. So the first place I'm going to take you is to the RISC-V instruction set manual. That's where almost all of the interesting stuff comes up with regard to these implementation, either the instruction or the CSR. The privilege spec is where we talk about CSRs in the sense of because CSRs have protection around them and there's privileged access to the CSRs, that's why those things sit in the privilege spec and why we'll discuss those in looking at the other spec. Okay, so if you go to the spec and you wind your way through it, you'll eventually come to chapter 26 of the MPriv spec, and it's called Extending the RISC-V. And as you might guess, it's several pages of how you might go about adding an extension, an instruction to the instruction set. And this is guaranteed non-standard encoding space. Okay, RISC-V architecture, you're not going to implement ever anything in this space. You're allowed to use it. Having said that, let's talk a little bit about base instruction formats, just so that you know what we're talking about as far as opcodes and how they work. This is figure 2.2 in that same specification, and it shows the 4 basic types of opcode encodings. Opcode encodings are the things that you're going to be interested in if you're developing an instruction. And now, having shown you this picture and having told you that that's what you're going to do, is I'm going to completely ignore that and generate my own type of opcode. I call it an X type, and you'll find out why I call it an X type in a little bit. It has to do with the naming conventions that we follow within RISC-V. Mainly because I wanted to see if I could do it, if I could just use a particular arbitrary type. Now, the one thing that's not arbitrary is the opcode. The opcode, the first 7 bits, let me rephrase it, the least significant bits in the instruction, the 7 least significant bits encode the opcode. And that's important for decode. Notice the warning I put here. Me using an X type is not the way you're probably going to want to go. I did that just as an exercise, kind of a general exercise. You're probably going to want to encode using one of these basic encoding types. All right, so now we know that there is reserved encoding space. Well, where is it and what is it? So you go to chapter 24 of the spec, where you'll have the instruction set listings. It's a long chapter. The most important part for our discussion is the first table in the chapter. You find out the space that is reserved for a custom instruction, and custom 0, custom 1, and it shows you the encoding bits for the INST bits of the opcode. Okay. Notice also that I'm talking about 32-bit opcodes. You'll have to do the exercise if you're going to implement a 64-bit opcode. Okay. Another thing that I ought to mention is that we have a naming convention within RISC-V on how we name extensions. Most of you who have done anything either with the tool chain or implementation know that there is a standard naming convention. Non-standard extensions are named using a single X, capital X, as an extension name. So anytime you add a custom extension, you're going to want to have it prefixed with an X. I'll show you what I do for my instruction. My instruction is going to be XMPL, for example. Okay. Now, we've covered what the specs have to say about adding an extension and getting an opcode and what opcode you should use. It turns out that doing opcodes and doing an instruction is actually pretty simple. It's not difficult. And as we go through the exercise, you'll go, well, that doesn't look that hard. It's not. The CSRs do have a bit more programming. You have to be more cognizant of more files. And so adding a CSR is a little bit more difficult, but we'll go through each of the places that you're going to need to touch when you add a CSR to the Sail model. We move on to the privileged architecture spec, because that's where they talk about, that's where it's talked about the addition of CSR and CSR space. So you'll notice in several places where you can have custom CSRs, there's space allocated for the various custom CSRs. Notice also that you have protection mechanism, a privilege mechanism associated with each address. So you have user level CSRs, supervisor, hypervisor, and machine level CSRs. For the purposes of our example today, we're going to use this address space for a machine level CSR. And that's where we're going to put our address for our CSR. Okay. What else do I want to say about this? There is a coding style guideline in the RISC-V Sail repository that you need to follow. We have some success in getting people to follow that coding style, and there's a lot of feedback that's given during PR reviews to get them consistent with a code style. If you look at the very top level at the GitHub repository for the Sail model, you'll find codestyle.md. Please follow that if you're going to implement. A lot of you are going to be frustrated with it because it's a different kind of coding style than you might be familiar with. Certainly I was and am, but we want to have our code look similar to the best of our ability. Okay, so let's be clear about what we're going to implement in the example. Okay, the name of the instruction that we're going to implement is called XMPL. The CSR is going to be XMPL CSR, and for the purposes of this discussion, we'll get into it. I actually implemented two CSRs for some experimentation purposes. We're only going to do anything with one of them, and it's actually going to be called XMPL CSR _2. The instruction is really simple. It's going to take an unsigned immediate that gets encoded into the instruction, puts that value into the CSR. It's like a CSR write, but I'm not using the CSR write instructions. Okay. The XMPL CSR can be read using the normal CSR instructions. Okay. So you can't write to it using CSR instructions, but you can read from it. The purpose of this is I want to see what happens if you try and write a read-only CSR. See how Sail handles that, how the model handles that. So we're going to take a few minutes and talk about that as well. So adding an instruction, pretty simple thing to do. You're going to add a file. and make a modification to a makefile. Adding a CSR is more difficult. And I have the list of files here that we're going to go through as we work our way through this. Please ignore the spelling errors that I have in here. My apologies. The first thing we're going to look at is the custom example instruction. So it's the example, so that's the instruction and how it affects a CSR. Makefile, pretty simple change to the makefile that needs to be made. This actually does not need to be, I need to remove this. This one actually is not used in this example. We don't do anything with this file. The CSR map contains the address map of the CSRs. We have to add some CSR functionality in the ZICSR file. There's some mapping files that need to go on for the CSR. And then there's a support function that talks about, is the CSR defined? We have to make a change there. For testing, we're going to take a look at how I tested this. It's a real simple test, just to make sure that now once you've compiled the model, can you actually access the CSR and read the value back? Okay. I'm not seeing any questions, so we're going to continue on. I know I'm just prattling on here. It feels kind of funny just talking to space and not getting any feedback. But Q&A is coming. You'll be able to ask your questions. All right. So let's take a look at the custom example Sail code. If you're not familiar with Sail, one of the first things you need to go do is go look at the Sail cookbook and the Sail manual that comes with the Sail language. That particular manual, I look at the Sail manual is kind of a reference manual. And there were some things that were missing there that the cookbook we thought would be useful to have good programming examples that actually work. When I say actually work, the code in the Sail manual actually works, but you don't have any way of compiling and building and making and testing some of the stuff. So the cookbook was meant to take care of some of those. All right. Let's see. So the first thing that we want to talk about is we're going to create a clause, an AST clause. And what this is essentially a type, an opcode type. Now, this clause is part of a scatter and gather operation within the model. And if you look at the Sail code, you'll see the idea is that you have these structures that you want to build, but they're scattered across many files. So encode decode is a clause, AST is a clause, execute is a clause. All of these are things that all instructions are going to need to implement, and they all get combined into one structure at the end of the compilation phase. It's the idea of being able to spread out your definition into files and then be able to bring them together, to gather them together into one structure that can be used, the compiler can then use. So these are all things that are scattered across different files and then gathered. So this X type that I've created says that we're going to have a 25-bit vector at the top, and then you're going to have an XOP. Now, well, what's an XOP? Well, let's move to the next mapping, which is of interest. I create an encode decode mapping called XOP for the XMPL. It's 7 bits wide, and this is the encoding. Okay. So this is the reference name. This is the actual bit value. And if you recall, when I showed you the encoding of the opcodes, there were 7 bits, and we saw where the custom 0 and custom 1 encodings were. Well, that's what I've extracted here for that particular instruction. So that's the opcode. That's the the meaningful portion of the opcode to say what instruction are you going to execute. Okay, so that's the first thing. We've got the opcode now defined, the first 7 bits of the instruction. We now have an encode decode mapping of type X type. And the way it constructs the vector or the actual opcode is along these lines right here. So you take the immediate value at the high end of the opcode, and then you pull in the 7 bits of opcode. So now we're mapping a type to an actual vector. Okay, so that immediate is something that's going to be pulled out by the assembler to say, here's the immediate value that needs to be plugged in. All right, so now we know how to encode and decode an instruction. Now we need to say, okay, that's fine and well, Bill. Make it do something. Okay, I'm going to make it do something, but it's not terribly interesting. I wanted to keep this brief and simple. So this is the execute clause. So the model comes along, it pulls in the opcode and says, okay, let's go find out what this opcode is and see if it maps to any instruction. And lo and behold, it comes along and it sees that there is an X type that matches this. And now that we see that there is, we're going to go execute it. Okay, so what do we do? Well, the first thing I do is I create this variable, which is a bit vector that's 25 bits long. It's a decremented type, meaning it's telling the order of that bit vector. And I'm putting the immediate value into that CSR value. And then at this point, I'm going to put that value into the CSR register value, XMPL CSR2. Now, we haven't gotten to that yet because we haven't really defined it. But the point is I'm taking the value from the opcode and putting it into a defined CSR register that we're going to get to in just a minute. And I'm going to do a retire success. Real simple. Now, this particular, let me talk about how some of these things could be extended a little bit. Okay, so retire success is not the only retire option. There are other things that can go on. This is where you might have an exception that something may have gone wrong. You may have done something illegal and you can generate an exception. So you can do an exception at this point. There's several different results that you can have in the execute phase. In the mapping that we have up here, I've only implemented one instruction for this extension. If you're going to have multiple instructions in the extension, you can have more lines like this with different opcodes to say these are other instructions as part of this extension. Let's move on to this mapping right here, because here's another place where you might run into a place that would grow. In this particular case, what I'm saying is we're going to map an XOP to a string. And this has to do with the log file. As you're executing an instruction, it will print out the opcode, but we want to have the opcode mapped to a reasonable string. And in this particular case, for this particular instruction, the decode of that opcode will be an x.xmpl, saying that you've just executed that. You'll see that here in the log file when we actually run through the example. And this is the assembly. So this is the mnemonic. And you'll see that in the mapping clause assembly, you'll see how it gets, the string gets generated for the assembly string. So you'll have the mnemonic, and this is a concatenation operator in Sail with a space, and then the hex bits for the immediate value. So we'll see where that gets printed out. Okay, so there we go. there's an instruction, there's an implementation of an instruction. Now I fretted over how much stuff I wanted to put into this little code snippet. You can imagine that this could grow rather quickly. In reality, if you go out and look at the model, most of the instructions fit nice and terse and clear in a very succinct manner. It's very clear in a succinct manner. There are a few examples where things are more complicated. Load and store instructions, and anything that has to do with load and store instructions becomes complicated because now you have to do all sorts of things in load and store to do your checking. You have PMP checks, you have the virtual memory interface that you have to be cognizant of. You have to be aware of the fact that there are exceptions. What happens if the load or the store doesn't complete correctly? What do you do? What do you do with misaligned instructions? So all of those make the load and store instructions, if you look at them in the Sail model, as being pretty complicated. Most of the instructions are really quite simple. This is the value of Sail. It specifies, and I look at this and think that's a nice specification for an ISA instruction. My editorial comment. You may disagree. I think there are other people who agree with that as well, is that it's a nice language for programming an ISA. Okay, let's move on to the next file, the make file. Okay, now that you have added this file, put it in the model directory, you need to add it to the list of files that need to be compiled. And all you do in the make file is add that instruction to this particular make variable. Okay, that's pretty simple. That's the easy part of the problem. And in 15 minutes, I've got to finish up the CSR discussion. Man, I feel like I'm talking 100 miles an hour. All right. Okay, we're going to talk about two CSRs. I'm only going to use one. The artifact here is mainly for my edification on figuring out the type system around CSRs. And so I was playing around with two different XML PL CSRs. In the CSR map.sail file, somewhere around line 115, 120, you're going to find a place where you're going to want to put in the address for your registers. And if you remember from the list of the CSR listings, this is the address space that I'm allowed to use for a custom CSR. Okay, so that just gives you the address and the name. Okay. Now, the code that actually does the read and the write of the CSR, boy, I got another typo in here, is in the ZI CSR Sail file. There are two functions in there that are important. One is the read CSR, and there's a complementary write CSR. If you remember, I'm not allowing a write to this CSR. I'm only allowing a read. So I only implement the read CSR function. I only implement a portion in the read CSR. And this is where we run into the place where the read is being done. Okay, this is the code that you have to add. Notice that the distinguishing factor between these two, and this is something that I talked with Alistar about, is that you really want this particular construct, the .bits constructor, rather than just trying to access the CSR directly. And there's a reason for that, and we won't go into it right now. The emphasis on this is there's strong type checking that goes on in this, and this is the thing that fixed the problem that I was running into on writing reading the value from the CSR. All right, on to the next file. There is a function that's of importance called isCSRDefined that is in the syscontrol sail.file. And you're just going to add this to the list of defined CSRs. And the other thing that it adds to it is, well, how is it accessible? What's the privilege mode? That's the accessibility of it. So you open up that file, look for isCSRDefined, and put in your new CSR in this area. Okay. So that's the code. You make all of these changes and put them in place, and now you're going to want to compile. We're now into the part where you've done all of the work that you think is necessary. Now you're going to compile it. And this is the step that's going to frustrate you, because almost certainly at some point you're going to run into a typing problem for one reason or another, and you're going to have to figure out what the type problem is. But this is how you compile the C emulator, the C simulator. Side note on this. The compilation mechanism for the RISC-V model, you can actually compile into multiple languages, two in particular, C, which is what we use, and OCaml. So for the purposes of what you're going to do and for the supported RISC-V Sail model that we support, you're going to create the C simulator. Okay. OCaml I haven't even touched. I don't know anything about the language, and I don't know what would need to be added to do any kind of OCaml work. Pause, rewind for a second. And I'm sure Alan Baum is chomping at the bit to want to say something, and that has to do with the execute phase right here. One of the things that's going to have to happen, and we don't have this in place yet, is you have to do a legalize function at some point. There are lots of examples in the model of a legalized function when accessing the CSR, and this is essentially saying, is this a legal thing to do to this CSR? The one thing that's just biting us in the rear end over and over again are WARL fields. Read any, read legal is what a WARL field is. And essentially an implementation can define for itself what the legal values are in a WARL field. Well, how do you configure the Sail model to get only the legal values that an implementation has put in? And we're still working on that, and I intend to extend this example to handle a WARL field. But there's currently, the way the model works, there's no way of specifying that. There's no way of saying what the user, how has the user configured their WARL fields. The solution to this is going to be using the RISC-V config structures, the YAML structures that tell you in that structure what the user is allowing for those WARL fields. But right now we don't have the method for bringing those specifications for those WARL fields into Sail. And when I say we don't have it, I have a pull request out there on how to do some of this, but not all of it. And we're still working to get this resolved. Configuration of the Sail model is one of the main problems that we have today, one of the main features that we really need to have in place. So that's an aside. Someplace in here, you're going to want to probably write a legalization function that does an analysis of, are you doing something legal or illegal? And then you have to decide what to do about that. In other words, the return value might not be retire success. It might be something else. It might raise an exception. Okay, that was my aside that I meant to mention earlier and didn't. All right, we're rushing right on through here. So if you get through this portion right here and you've created the CSIM model and it compiled correctly, good for you. Now, what are you going to do with it? Now you really want to test it, don't you? You really want to do something that makes sure that your instruction at least does something right. Does it decode? Whatever. So I've included in this PDF document entire test listing. I don't know why I did that. There's really only a very small portion of this test code that you need to be aware of. On the other hand, the test code, you really need to have almost all of this stuff in place in order to have a test that executes to some degree. And it's something that you will almost always want to use as the beginnings of a test, an assembly language test. The thing that I want to point out to you are these things right here. because this is if you've added an instruction, you almost certainly don't have a tool chain that has that instruction in it. In other words, you don't have an assembler that understands the mnemonic XMPL. It doesn't exist. Well, maybe you do. Maybe you're a tool chain guy, tool chain gal, and you know how to do that. And so you can change the new assembler to do that. For me, I don't have any of that expertise, but I do want to write a reasonable test that is intelligent, that's intelligible. Okay, so the way we do that is using some defines in the macro assembler. The first one is to define the opcode. That's the opcode right there, which has to do with the opcode extension that we talked about earlier. And then I'm going to define the actual instruction. Okay, XMPL, the destination register, which really isn't anything, and the immediate value. Notice that we don't. Well, sorry, this RD is a wrong nomenclature for this. That usually means the destination register. This is used for the actual opcode, and that's the way we construct it. Notice that it has a word directive. This is incorrect. So I have a problem here in this code. This definition is incorrect with a destination register. We'll come back to that, or I'll fix this. So now we have the definitions of a bunch of other things that are RISC-V specific, and now we're going to go down to the real test. This is the prelude to the test. We do a PMP configuration. We actually do something with a trap vector, and this is the test, which isn't a whole lot, right? I create the instruction. I give it a destination register, and I give it the immediate value, and then I'm going to read back the value. In this particular instruction right here, I wanted to find out what happens when we do a write to a read-only register. Okay, and so that's commented out, as you will know, and you'll actually take a trap at this particular point if you try and execute this bit of code. So that's how you do the testing. You'll compile this with an assembler. If you look at the dump file, after you do the compilation and do the dump of the ELF file, you'll see this bit of code in it. Okay. The opcoder is encoded in these bits right here, and then the immediate is up here, and then you have the CSR read instruction. The disassembler has no idea what to do with the opcode, this opcode. So what it does is it just drops in the word and says, here's the opcode we're going to execute, but we don't know how to disassemble it. When you run the simulator, this is the command you would use to run the simulator. You give it the simulation name. It's found under the C emulator directory. And there's the executable. You pass in the ELF file, and you'll get a log file. Actually, you'll get print statements coming to standard out, and just tee those off into a file, and then go look for the instruction that you're trying to execute. And what you'll see is the fetch and the execute. And because we've added that assembly directive in the instruction, we now know how to decode this instruction. And there's the decode value. That's the decimal value of the hex value that we put in. All right. And here's the read of the instruction.
Maybe just a quick comment. So we have 5 minutes left.
Yeah.
But we can extend this a bit more. Don't worry.
Okay. If you get to that point, you've actually implemented something. You're actually you've bootstrapped your way up and are getting things to run. There's a few other things that I want to mention that it should be a topic of an example, but I knew that I was going to run out of time, and I really run out of time. It's first thing to say, the Sail model is actually divided into two parts. The Sail model itself, written in Sail, and then there's a C interface. And a significant amount of features are implemented in the C side of the model. It's essentially the thing that interacts with the system. And there's a method whereby Sail can see C structures and C can see Sail structures, and you can call methods between the two. It's a very nice foreign language interface. So if you can write something in C, you can see it via Sail, and vice versa. From C, you can peek into the Sail structure and get some information out. For example, you can call a Sail function from C if that's something that you want to do. Now, having said that, let me give you some examples of some things that you will probably have to put into place and the things that I've run into. And that has to do with command line options. You may want to add a command line option to enable or disable a feature. That's something that I've wrung out, know how to do, but I don't have the code in here in this example to do that. And that will be an example that'll be added later. What else to say? These are just the list of those functions and how you might make use of them. The one example that I'm working on right now is that Philip Tomsich developed, not ZFNX, sorry, that's another example. He did the Z icon extension, and we need to be able to turn that on and turn that off. And so there were two switches that we needed to add support for. And and it's one of the things I'm actively working on right now. One of the things that went along with that was an experimental switch, which is coming very soon. And then another example is we need to do write the code for handling WORL fields based on setting in the YAML files. And this is a chicken and egg problem, and I'm trying to figure out what the right way to order these things are to get a good configuration of the Sail model. All right, I've run through that at breakneck speed. I'm hoping that between the description and the PDF file and what I've said verbally, you won't get too messed up on trying to add an instruction. One thing I will do is fix that problem with the test.s file. That's remnants from another thing that needs to be fixed. My apologies for that. Okay, questions?
Alan added some comments. I'm not sure if he is willing to share those verbally.
Are they in the chat window?
Yeah, they're in the chat. They're in the question and answer window, actually, but I can unmute now, so I did. In your CSR example, the RISC-V spec has CSRs in buckets, which privilege level, whether they're read and write, whether they're custom and standard, and I think there's one more, I don't remember. When you're defining a CSR, do you have, and you have a CSR address, do you have to specify all that, or can you inherit that effectively?
You inherit that.
Cool. All right. So if you try to write something that's in read-only space, it will trap, and you don't have to worry about writing the code to do that.
That's right.
All right. And you made a comment about, oh yeah, I didn't think that you ever get a CSR that traps on reading and writing them because of the contents of any field. You can trap because you're reading something or writing something you're not allowed to read or write, but there's nothing that I think that allows you to trap because of the value you're trying to write or the value you're trying to read, for that matter. Well,
that's true for all the CSRs that we have, and in general, I think that will be the rule. My point is that you could trap if you wanted to.
Okay.
You have that control in the execute phase.
Okay, and then about assembling custom stuff. There's an assembler construct .insn. And if you're defining a new instruction with the standard format, you don't have to worry about, you can just use that construct to fill in the RD and the RS1 and the RS2 and in intermediate fields. Much easier way to do that.
Yeah. It wouldn't work for my example, but in general, the general solution. So I was not aware of that. That would be very useful. Make much more readable code.
Yeah, and I don't know how to add. I mean, this construct is built into our assembler, and it knows about the format types. I and R
and
J. I don't know how you would add that to the a new format to the assembler. This only works for existing formats.
That's good to know. I should add that to the cookbook to let people know that there's an advantage in using the defined instruction encoding types.
Yeah, that was my point. Although there are instructions that exist that don't quite follow the standards. I was thinking especially the fence op, which it doesn't have a signed immediate. It has just a bit vector immediate, which is slightly different, and Sail would complain about that.
Okay.
That's a type error, basically.
Yeah. All right. I hope that's been helpful. We can continue on with the Q&As if there are. I'll make an offer. There's an awful lot of stuff going on in Sail, and there's a lot of little presentations we could do in these kind of talks. If this was at all helpful and you'd like to see more, please let Raphael and myself know, and we'll schedule them. If you're really interested in this kind of stuff, the Tech Golden Model meeting is the place to be. Sometimes we do technical updates. Most of the time it's getting status of what's going on and who's working on what. I should also mention that the Dev Partners meeting that Jeff Schill runs is also really valuable if you want to contribute you or your company's resources to doing work on either ACTs or the Sail model. We need help in both. ACTs and Sail are both, we're limited by the number of people that we have, and would really like to have help working on this.
Yes, yeah, I think we do need another session anytime soon, so we can schedule that and send the invitation for everyone. We do not have any other questions.
Well, Hongzhang Shan asked where you can get the cookbook. So Hongzhang, the presentation, the link to this presentation is available in the chat window. And in that presentation, there is a link to the GitHub repository that has the cookbook. Keep in mind, folks, that cookbook is a living document. It is going to change as time goes by, especially in the next few months as we add more coding examples. So just keep that in mind. If you print it out, by the time you get it done printing it out, it's probably going to be out of date. So just pay attention to the online reference.
Yeah, and this session will be available, I believe by tomorrow, and I'm going to share the link with everyone so you can watch it again if need be.
We should find a way to add some of these links to the official RISC-V like wiki pages or something, so people can find them and don't have to look at some giant string.
Yeah.
Work on that.
All right. Thank you very much for attending. Appreciate it. Please give feedback. I've got a thick skin. If you really hated it and wanted to see something done different, let me know. I'm flexible.
Oh yeah, someone raised their hand.
Oh, hi. I'm writing Sail model for the SPMP extension and haven't tested yet. So I want to know how can I contribute to or get help from the Sail group?
So are you specifically talking about testing PMP? And did you say ePMP?
No,
SPMP, S mode, physical memory protection.
So contact me, bill@risc5.org, and contact Alan if you're interested in writing ACTs for that. We actually have some good patterns for the PMP type stuff. Yeah,
that one's particularly tricky to get good tests. Very tricky.
Okay, thank you.
If you haven't noticed, Al and I are kind of joined at the hip. He's responsible for ACTs, and he's got a heavy workload there. It's hard to write good, robust tests, and I'm to provide the Sail model that he uses as a reference model for the test. So we spend a lot of time talking to each other. So if you contact me, I'll ping him, and vice versa. I would guess.
Yeah, and I'd have to say the reason that it's particularly tricky to write tests for PMP especially is because you have to write tests that work for basically anybody's implementation of SPMP. And SPMP, unless you define it carefully, doesn't really limit the minimum number of PMP registers or what numbers they are or anything about their ordering. And that makes it really difficult to test. So if you want to make it easier to test, define SPMP so that you can only have registers starting with 0 and ending with some number, and having a minimum number of about 6 is really necessary to do good tests. And that's just
Okay,
a minimum number.
Okay, thank you.
All right, I think we're all done.
Yeah. Thank you very much, everyone, for joining.
Yeah.
Thank you, Bill. Thanks a lot. And thank you, Alan, for all the comments.
Okay,
All right.
bye.
Bye-bye.